This video introduces our work of object contact estimation with regional unwrapping transformer. Our goal is to estimate non-rigid contact patterns from the monocular RGB image. Existing monocular hand-object reconstruction methods introduce contact constraints during training, but there may still be unrealistic grasping during inference. Recently, some works use explicit contact inference and enforcement to achieve higher quality grasps. However, existing learning-based methods focus more on contact with rigid ones from monocular images. When adopting them for non-rigid contact, a major problem is that the existing contact representation is restricted by the geometry of the object. Consequently, contact neighborhoods are stored in an unordered manner and contact features are difficult to align with image cues. Our key idea is to propose a novel hand-object contact representation called RUPs, which unwrap the roughly estimated hand-object surfaces as multiple high-resolution 2D regional profiles. The region grouping strategy is consistent with the hand kinematic bone division because they are the primitive initiators for a composite contact pattern. The correlated hand-object subsurfaces for each region are aligned according to rays emanating from the center and unwrapped to the 2D regional profiles. Based on RUPs, RUformer is proposed to learn the correlation priors across regions from monocular inputs and predict corresponding contact and deformation. Firstly, we prepare RUformer input data, all of which are aligned to the hand's 16 regions. The hand-object surfaces are estimated and unwrapped into multiple high-resolution 2D regional profiles. The image patches are cropped using the guidance of hand joint image coordinates and mano-pose is converted as bone transformations. Then, we estimate hand-object regional contact and deformed degrees of contact areas from RUPs, image patches, and hand bone transformation. We represent hand contact as 2D maps on hand RUPS and object contact as 2D maps on object RUPS. For each pixel on the object RUPs, it corresponds to a point on the object surface. With the help of deformed degrees of contact areas, the coarse deformation of contact points can be obtained. The coarse deformation of the contact point is the maximum deformation multiplied by the predicted deformed degree. However, the deformation obtained in this way does not consider the deformation priori of local geometries and lacks the understanding of the global deformation behavior. Therefore, we aggregate deformation features from grid-wise sampling points and estimate fine-grained deformation. We divide the object RUPS and object FRUPS into multiple grids and sample points from each grid in an orderly manner. We inherit the idea of the deformation graph that represents the deformation of arbitrary points on the surface as a combined deformation of nearby nodes. Our deformation estimation network is designed to select NQ nodes from NP points and predict their affine transformations according to grid-wise sampling features. Based on hand-object contact maps and deformation transformations, we refine the hand and object surfaces. Our experiments demonstrate that the proposed framework can robustly estimate the deformed degrees and deformed transformations, which makes it suitable for both non-rigid and rigid contact. In the task of reconstructing the hand object from the monocular image, our methods can achieve more plausible reconstructions with fewer penetrations than previous work. The comparisons on contact patterns optimization demonstrate that our method can be applied to both non-rigid and rigid interactions and achieve higher quality grasping. Thanks for watching.